Welcome to Startup Hack. Today we are going to talk about static helper class versus injected service. So let's jump right in. Make sure to check out the link down below because we always provide the code samples that you can pull down and follow along so you can see in our project. Alright, in terms of testing the extracted logic in isolation, there typically isn't much differences between static and instantiable classes. In both cases, we need to set up our tests in similar ways. With pure functions, the main difference would be how we invoke the methods to be tested, that is, whether we need a class instance. The exception to this would be where state is involved. In this case, we need to remember to reset our classes between tests and also be mindful about running them in parallel. This is easier with instantiable classes because we can create a new instance per test, something that isn't possible with a static class. So the main advantage of static class lies in its simplicity. Once created, its public methods immediately become available for use anywhere within a code base. There's no need to consider creating additional interfaces, no need to tweak IOC framework modules, and no need to modify the constructor parameters of any classes. For this reason, a static class can be a good choice for self-contained helper methods that form a part of an importable class library, possibility via NuGet. However, this simplicity is also a double-edged sword. A static class will have separate code in source form and it will help in the following the dry principle, but it doesn't reduce coupling between responsible. Whether this is a problem depends on the context. A good example of where using a static class makes sense is system.math. The functions it contains return values that are widely accepted to be corrected. There's no need to set them up with input or output value pairs and returning anything another than what they do typically isn't useful, not even for testing purposes. So let's contrast this with logic for calculating a password hash, for example. While this should be produce consistent results, there is value in mocking its outputs in tests. Imagine writing a test that verifies a method, takes a password string, hash the password into a long hash value, compare it against a known value in the test assertion. If real hashing algorithm is used so it could be unnecessary increase the time it takes for the test to run. More importantly, it reduces its focus. Instead of only checking that the process is followed, we had also be incorporating knowledge without the output hash. While testing the password transformation is important, it can and should be done in a separate test. Lastly, if we ever change the hashing algorithm, we need to update the test. So here's example. I have created static class as well and injected service as well, instantiable class. So as you can see here, I have used this in the main program by using instantiable method, and this is the static helper class. Do you want to earn $100,000 a year? Do you want to become a software developer within just 3 months? With our amazing course and awesome tutors, you never have to worry about getting stuck. We help students to learn skills that companies want to hire. We are Startup Hack. Don't forget to subscribe our channel. So let's get started. So we have a static helper class, password hash helper with a static method hash password, which takes a password string as input and returns its SHA-256 hash value. We also have an instantiable class, password hash service with a method hash password, which does the same as the static helper class. In the main method, we demonstrate both as approaches to hash password. This code illustrate the usage of both static helper classes and instantiable classes for implementing the single responsibility principle, providing flexibility and maintainability in different contexts. So I'm going to run this application and see the output. So as you can see, both have hashed the password successfully. So thank you for watching this video. When refactoring code into separate classes, you can often choose between creating new static or instantiable classes. The best choice of it depends on context. When you create a static class, you will build a solution that's easy to use and requires minimal changes, if any, to integrate. These are often a good choice for standalone logic where functions have widely accepted exceptions or conversion results. By creating an instantiable class, you will allow for more flexibility by decoupling separate concepts. While needing a bit more effort to incorporate, you will find it can be easier to write tests for and run in parallel. As a bonus, you might be able to avoid modifying your tests if you ever need to change your implementations. So don't forget to subscribe our channel and hit the bell icon for latest updates. To joining our course, you can simply go to our website called startuphack.com. Thank you.